Hi guys, this lesson is on word problems. And so looking at these word problems, we are going to first read the problem so that we understand what's going on. And then we're going to choose the appropriate setup. So do we need a table or chart? Do we need to draw a picture? Is there a formula that's going to work? Is it a certain type like a work or a mixture or a money or a number or a distance problem? So each one of those will have a clue as to what we should do. And then finally we're going to solve our equation. So for our first example, we have a motorbike that travels 40 miles and a bicycle travels 15 miles in the same amount of time. The rate of the bicycle is 20 miles an hour less than the rate of the motorbike, which makes sense. And they want us to find the rate of each. So in other words, the speed that each one is going. And our time is found by dividing the distance by the rate. So this is based on this formula here, distance equals rate times time. So the time is, like if we solve for time, we would be dividing by r. So distance over rate is equal to time. Okay, so I find it helpful in this case to make a chart. And so we have a line for our motorcycle and a line for our bicycle. And we have the rate, the time, and then we know it will equal the distance if I multiply rate times time. So I'm just setting all of those pieces of information into a chart. So the motorcycle was traveling at a distance of 40 miles, and the bicycle was going 15 miles. And they went this in the same amount of time, but we did not know their rates. So the rate of the motorcycle is something we don't know. We do know that the bicycle was 20 miles an hour less than that, so I can represent that with x minus 20. So whatever the motorcycle is going, the bicycle is going 20 less miles per hour than that. And then the time, as we were talking about, is the distance divided by the rate. So in the case of the motorcycle, the distance was 40, the rate was x, so we can represent time as 40 over x. In the bicycle, the distance is 15, and the rate is x minus 20, so we'll do 15 over x minus 20. So there is our time. Now, the thing about this problem is that these times are the same amount. Whatever they equal come out to be, it is the same amount of time that this is happening. So that is the key to getting this. So you want to set those two equations equal to each other. So 40 over x is going to equal 15 over x minus 20. And that makes this a rational equation. So if we're looking for the common denominator, we're going to multiply both sides by x and x minus 20 because those are different. So I'm doing the 40 over x times x and x minus 20, and the 15 over x minus 20 times x and x minus 20 because those are our common denominator parts. And then I'll cancel. Here I can cancel out the x's, and I would have the 40 times the x minus 20. Here I'll cancel out the x minus 20s and have the 15 times the x. Then I'm down to an equation that doesn't have fractions anymore, so I want to distribute in the 40 to get myself 40x minus 800 equals 15x. Now, to further solve this equation, I want to get the x's together, so the 40x and the 15x. I'm going to subtract the 40x to both sides and get the negative 25x, because 15 minus 40 will be negative 25. And I still have the negative 800. And finally, I want to divide both sides by negative 25. So x will end up to be 32. Now, if you remember, x represented the rate of the motorcycle. So I know that the motorcycle is going 32 miles an hour, which means that if I subtract 20 from that, I will get the rate of the bicycle, and that will be 12 miles per hour. Okay, this next type of problem is a mixture kind of problem, and we're going to do several different ones of these. So we have a pharmacist that has 8 liters of a 6% alcohol solution. How much water should be added to obtain a 4% alcohol solution? So we want to dilute it here. So I look at it as I've got these 3 containers. I'm adding this original solution plus some water and getting this new solution mixture. So this first one is what we started with, 8 liters at 6% of alcohol. The next one is some amount of water at 0% alcohol. And the last one is adding those together, because obviously if you start with 8 liters and you add some to it, you're going to have however much that is, 8 plus however many liters, and we want that to be a 4% alcohol solution. So these are the setups. Now, what's nice is that easily turns into an equation. So once you have that drawn out and listed, you just have to turn the percentages into decimals by moving 2 places to the left. So 6%, you move 2 places, you get 0.06. 4, you move 2 places, you get 0.04. So you're doing the amount times the percent as a decimal. So 8 times 0.06, x times 0, and then 4% is 0.04 times the 8 plus x. Now if I multiply that, 8 times 0.06, I'll get 0.48. 0 times anything is 0, so I kind of drop that off. And then over here I do have to distribute that in, so 0.04 times 8 will be 0.32, and 0.04 times x is just 0.04x. Now again, I'm trying to solve for this equation, so I need to get the 0.48 and the 0.32 together. So I'm going to subtract the 0.32 from both sides. That leaves me with 0.16 on the left and 0.04x on the right, and then I'll divide by 0.04. And that will give me 4 liters. So that is how many liters of water I should add to dilute this down to a 4% mixture. Alright, here's another one. We have a chemist with 80 milliliters of a 6% acid solution. How much water should be evaporated so that the remaining solution is 8% acid? So if we're taking water out, it's going to be stronger, so that should make sense here. Now, when I think of this, I'm going to look at it again in the same way. I'm starting with 80 milliliters at 6%, but because I'm evaporating, I'm going to subtract water. I don't know how much, but water is 0% acid. And what I get is going to be some amount, 80 minus x, at 8%. Okay, so the amount, we started with 80, we took x away, and we ended with 80 minus x, and then our percentages, we went from 6% to 8% because we took some water out. Again, I'm going to multiply the amount times the percent as a decimal, so 80 times 0.06 minus 0x is 0.08 times 80 minus x. And again, when I multiply, I get 4.8. The 0x will go away. And I need to distribute over here on the right. So 0.08 times 80 will be 6.4, and 0.08 times negative x will be negative 0.08. I want to get my number parts together. So I'm going to subtract the 0.64 from both sides. And I get a negative 1.6 is a negative 0.08x. I'm just bringing that one down. Divide by negative 0.08. And I get 20 milliliters of water. So negative 1.6 divided by negative 0.08 will be 20 milliliters. And that's just telling me how much water I should have, because that's what X stood for. Alright, on the next one, how much pure alcohol must be added to a 4 liter of 10% alcohol solution to make the solution 20% alcohol? Now, when we say pure alcohol, we're talking 100% alcohol. So, we have some amount at 100% alcohol. Adding that to a solution that is 4 liters and 10% alcohol is going to equal the amount, x plus 4, and the percentage we're aiming for is 20. So I set all that up, and then I'm going to turn everything into decimals. Now, notice with 100, if you move the decimal 2 places to the left, you get a 1. So you get 1x here, and then 4 times 0.10, and then 0.20 times x plus 4. So you're just multiplying each of those pairs. And here I'll have to distribute the 0.20 in. The 4 times 0.10 is 0.4. 0.20 times x will be the 0.2x, and then 0.20 times 4 will be 0.8. I need to get my x's together, and I need to get my numbers together. So I'm going to subtract 0.2x from both sides, and I'm going to subtract 0.4 from both sides. So what that's going to do is make the 0.4's go away here, and the x's go away here. So I'll have x's on the left and numbers on the right. And so 1 minus 0.2 will be 0.8. So you don't forget that that's a 1. And then over here, 0.8 minus 0.4 would also be 0.4. And then finally, I'll divide by 0.8 because I'm trying to get the x by itself. And I'll get 0.5 liters of pure alcohol. All right, now we're going to a money problem, investing money. We are investing $3,600. We're going to put part at 8% interest and the rest at 7% interest. So two different accounts basically. And if the total income from the investments was $274, in other words, that's how much interest was earned on both of them, not the total amount in the bank, because it should not go down like that. We want to know how much did she invest at each rate. So this is just the interest earned. So there's a money formula you need to know. Is interest equals the principal times the rate. So again, the I stands for the interest. P is the principal investment. That means that beginning amount that you start with. And then, so in this case, it's $3,600, but in two different parts. And then the rate is like the 0.8 or 0.08 or 0.07, the percentages that they're earning interest at. So again, I'm going to use a table here because it kind of lends itself to that. If I do the principal times the rate, I get the interest. So I'm just calling them the 8% and calling them the 7%, but those are the rates. So you'll notice under the rate column, it's 0.08 and 0.07 when I write those as decimals. And the principal, we know they have to add up to 3,600, but it's not necessarily even amounts. We don't know exactly how much is in each one. The way we express that is we just pick one and call it X, and the other one would be the total minus that. Just like if you had $100 and you know that 30 of it were going in one account, then you would subtract and know that 70 were going in the other account. So here, I'm just going to call one X and one the total minus X, in this case 3,600 minus X. Now we know by the formula if I multiply these two amounts I should get the interest. So I'm just multiplying here and writing the formula here under the interest column. So if I add those two interest formulas, I know that I should get $274 because they told me that's how much interest I ended up with. They just didn't tell me how much came from each account. So I'm taking those interest formulas and adding them together. And I do have to distribute the 0.07 in. So 0.07 times 3,600 will be 252. 0.07 times x here, but it was a minus. And then I'll combine like terms. So 0.08 and negative 0.07x will be 0.01x. And then I want to subtract the 252 from each side. And I get x to be 2,200. And I think I forgot to put a step in there. So what happens when you subtract the 274 minus the 252? You get, you subtract those and you get 22. But then you do have to take that 22 and divide it by the 0.01 that was in front of the x. And that was the step that I left off there, and I do apologize. So that is how I get 2,200. So what that means is $2,200 was invested at 8%, because that's what our X stood for, was the amount that was invested at 8%. But they wanted to know how much was in each account. So if we invested $3,600 total, and we know $2,200 was invested at 8%, then we just subtract and get $1,400, which would have been invested at 7%. And that concludes this lesson. Email me if you have any questions.